Welcome to Disaster Simulation Pro, a simulation system to model disaster relief procedures. We are a team of industrial engineering majors from UC Berkeley, comprised of Aaron Prohovsky, Sasha Patel, Cindy Mo, Surisha Varigonda, Raja Tolpuria, and Thomas Beck. We will be going over the issue at hand and an overview of our product before walking you through our model and finally showing you a live demo and explaining how we hope to build on our model in the future. When disasters occur, the surrounding area is ravished, so much of the necessary supplies must be brought in from distant areas. This leads to uncertainties and bottlenecks that slow down the relief process. Thus, when conducting disaster relief projects, preparation is critical to saving lives. This is the underlying motivation for Disaster Simulation Pro. The purpose of the simulation is to determine what needs to be done given various inputs to the system. The user inputs the distance of the medical hubs from the disaster location, the amount of starting medical supplies and starting workers at each hub, the magnitude of the disaster, and the frequency of medical deliveries. After the simulation runs, the output shows how many workers were needed, how much medical supplies were used, the number of people injured, and the inventory level of on-site medicine. By adjusting the various inputs, the user can easily carry out sensitivity analysis to determine the necessary resources for different circumstances. This is helpful because it allows the user to better understand how to prepare for various natural disasters. With this in mind, there are three main considerations that the product takes into account. What is the optimal number of workers that should be sent over? How much medicine must be sent over? And how close must the medical hubs be in relation to the disaster location?
Here's our verbal event graph. Our simulation begins when a disaster strikes. This triggers a few events to occur simultaneously. Injured citizens and workers arrive at on-site medical facilities, nearby medical hubs dispatch medicine to the disaster site, and companies involved in disaster relief dispatch medical supplies to the medical hubs. Not pictured here is a hidden node that allows us to model the arrival of injured people using a non-homogeneous Poisson process. The injured arrive, workers arrive, and dispatch medicine events trigger the start treatment event, provided that there is medicine available on-site and there are workers available to administer the treatment. Additionally, the worker arrive event schedules a worker leave event as workers end their work shifts. The dispatch medical supplies event schedules a medical supply expiration event, which will be canceled should the treatment with those supplies begin. Lastly, the start treatment event will schedule an end treatment event for the future to indicate a patient has healed. The end treatment event will schedule a start treatment event if there are still injured people that need to be treated and enough medical supplies and workers available. Now we'll take you through a demonstration of our product. Here's our product's Excel interface. These columns on the right are where the user can input various starting parameters. The initial number of medical supplies at each medhub, the starting number of workers, the distances from each medhub to the disaster site, the magnitude of the disaster, and finally the alpha and beta inputs to the beta function that determines medical supply restocking time. Now we're simulating our example. You will notice first off that the workers plot is significantly lower than the total bed plot. This is because one worker can help many injured people, but one unit of medical supplies can only be used once. Thus, they are required to have many more medical supplies. You can also see the interplay between inventory, that is medical supplies on site, and injured. They both start out with peaks and then level out in days following the natural disaster. From the graphs we can find the total number of workers sent for a given disaster, as well as the total number of medical supplies used. We can also find out how medicine hub locations affect our solution by adjusting the med hub distance parameters. Comparing plot 1 and plot 3, we can see the effect of a greater magnitude disaster. Approximately 4 times as many workers and medical supplies are required when the disaster has this greater magnitude. As we look to the future, there are a number of expansions to add to this product. First, we will implement a way to track the overall cost of the relief effort. Additionally, we will track how long an injured person waits before receiving medical attention. Finally, we will include more input parameters, such as multiple disaster types, not just magnitudes, more control over distributions, and more control over sending supplies to medhubs. Thank you for watching our demonstration of Disaster Simulation Pro. If you have any questions, feel free to email us at disastersimpro@gmail.com.